How does oxidative dye work on hair? Imagine transforming your hair color through a process that involves chemistry, precision, and a bit of science magic. When you see a box of hair dye labeled as oxidative, it hints at a complex interaction happening at the molecular level. Understanding this process can help you appreciate how your hair changes color and how different shades are achieved. Oxidative hair dyes contain two main components: an aromatic amine or phenol derivative known as a dye precursor, and an oxidizing agent, typically hydrogen peroxide. The dye precursors are small molecules that can penetrate the hair cuticle, which is the outermost layer of the hair shaft. Once inside the hair cortex, these molecules encounter the oxidizing agent, which triggers a chemical reaction. The hydrogen peroxide acts as a catalyst, oxidizing the dye precursors. This oxidation process transforms the small molecules into larger, colored molecules called chromophores. These chromophores are responsible for the new hair color. As they form, they also polymerize, meaning they link together to create larger structures that are permanently embedded within the hair cortex. The process begins with the hydrogen peroxide breaking down the natural melanin pigment in the hair, which is responsible for the hair's original color. This bleaching effect allows the new dye molecules to deposit more effectively. As the oxidation continues, the newly formed chromophores bond with the keratin proteins in the hair, resulting in a durable color change. The final shade depends on the specific dye precursors used, their concentration, and the duration of the application. Different combinations of precursors produce a wide spectrum of colors, from natural shades to vibrant hues. The chemical reactions are carefully controlled during manufacturing to ensure consistency and safety. In summary, oxidative dye works by using hydrogen peroxide to oxidize dye precursors that penetrate the hair shaft, then polymerize into larger molecules that bond within the hair structure. This process results in a permanent change in hair color, with the ability to create a broad range of shades through precise chemical reactions.